is the homework. Okay, so question one. You just look these up on your charts that I sent you and find out what is the smallest. That's all this is asking you to do. I'm not going to spend any time on that. Here are more definition type questions. So based on the notes I gave you, answer those questions. The t-value such that the area is to the right of 0.01. So you would go to the chart, go to 0.01, go to 25 degrees of freedom, and you should find this number. Okay, that's all you have to do. You also have an Excel. It's called inverse heat. Punch in that info and it should give it to you. Okay. Also, your TI-4 and I can do it. But the one I wanted to do with you, I think it was 5. Here we go. So they're giving us a random sample, size n. So n is it'll vary depending on which one we're doing. 114 will be our x bar. S is 10. So Excel is going to calculate the part we add and subtract 114 to create that confidence interval. Okay. So let's do part A. We can do all of them, but this is how I'm going to set it up. So all these numbers are, let's see. I'm going to write them in Excel in just a moment. Okay. So our question had X bar to be 114. N for part A is 22. S was 10. The alpha for part A is, so if they say construct 98, alpha is 2%. So put 0.02 here. Okay. I guess we will need everything. Degrees of freedom isn't necessary for this question, but I went ahead and said, you know what, I'll make this equal to n minus 1. So it'll just automatically give me the degrees of freedom, even though I just spam 1. Oh, I type too much. Anyway, the part that matters. So confidence, this is the value we're going to add and subtract from X bar. So hit equals confidence interval, confidence, CONF, choose the dot T. Here they're going to ask for the alpha, so just click it. Standard deviation is S was given, size was given. Okay, all that is given. So now what we're going to find in just a moment is this piece here. Okay, we already have X bar. So the upper bound would be X bar plus this value you found. Lower bound would be X bar minus this value I found. We called it, I just call it the CI value. I mean, it's not a proper name. But this would be the confidence interval. So you would say, oh, the mean is somewhere between the true mean. Let's round to one decimal place here. Shoot, lower first. Anyway, does that make sense? So what you can do, if you set it up this way, you can just kind of change the alpha and the n. We'll go back to the question. So it was 119 point whatever, 118. Go back to the actual question. Yeah, there it is, 119.4, 108.6. So for part B, just change the alpha and sample size, and you'll be good. So alpha is 2% and n is 11. For the next question, 11. What do we say? 0.02 as well? Yeah, they're both 98. Okay. Nothing else changed. Okay. So these are the same. Let's just drag this guy down. It should automatically select NS and alpha. So once you have that, do the same thing. Because I believe the X bar is also the same, right? We're using the one from here. So yeah, just add that value. So the plus version and the minus here. I guess I could have dragged that down too. So for part A through whatever, you can just drag these down. And just replace. The only thing you need to replace would be the N and alphas. So part B or C is 80% and N is 22. So 80% and 22. So 22, 0.2, right? Would be our alpha. There's our new confidence intervals for that. You can just change those and you'll be good. Anyway, that's pretty much it. Is there any questions on? I thought there'd be more of them, but just. Is that straightforward? How to do it with Excel? So numbers 5 and 6 would be similar. You just give them the lower and upper bound. Margin of error, use the for part 7 or question 7, use the formula I gave you. It should be fine. Yeah. Let's work on the homework and let me know if you get stuck. And you make sure you print out those charts I sent you. It might be needed on the exam.
But I'll make it up beforehand. They'll be out of town. Thursday, next week, Thursday.
You leave next Thursday?
And I come back on Sunday.
Oh, we can, when I come out, so you can Wednesday. We can do that. Okay. It's at 10:30 till 12. You can be there at those, during those times, it's gonna be there. Yeah, I'll leave at 12.